In this model, you can actually adjust the price if you wish to. And for those students that want to look beyond into the chapter and how they did extended evaluation, I provided some additional information here for the demand information when you're considering changes in demand. So we'll refer back to those at the end of the module. But the basic challenge is this forecast of original forecast of demand. We have a number of different inputs here: material cost per unit, inventory holding cost per unit, the stock out cost per unit, cost of hiring, the cost of firing, labor hours required per unit. That's an important new input that we haven't considered yet. In our constraints, we're going to define the labor hours required per unit and use that to calculate our regular time and the capacity in terms of we have regular time worker hours per month of 160, which we reviewed earlier, and the labor hours per month are going to be an important input to offset our calculation of production by the labor hours required per unit divided into the regular time per worker. The overtime cost per hour, here is that input that I mentioned. The maximum overtime hours per worker per month is going to be an important we're going to allow is 10 worker hours per month, like 2.5 hours a week. The subcontracting cost is $30 per unit. We defined that earlier. So these are all our inputs. Now our model will utilize those in the calculation. I'm going to zero out all of the inputs here in the optimal solution. You can see the inventory that we have beginning is equal to 1,000. We are going to, these are totals here. You can see these are, or excuse me, averages. These are used to calculate some inventory calculations that are provided in the text. They're not necessarily for the assignment. The total cost, though, is simply the sum of all of this, all of these costs here in this aggregate plan cost table. So the aggregate plan costs are going to be equal to the in the traditional way. I need to zoom this up here so you can see these. The cost of hiring is simply going to be this inputs refers to the cost of hiring one worker. B5 is what the solution will optimize as the number of people hired. Very much like the same example, or the example I used for Namias. For a laid off, same thing. The number of people laid off multiplied by the cost of laying off per worker. Regular time. Regular time is the number of workforce multiplied by the inputs B22 times 8 times 20. So if we look at the inputs, that is going to be in the inputs, B22, regular time per hour. That's what I didn't do. I didn't select that. I'm not sure I could navigate around. Well, I'll try that again. Regular time per hour times 8 hours times 20 work days per month. Okay? So that's how we calculate our regular time. So our regular time calculation is a function of our workforce size, assuming 160 work hours per month. Our overtime is going to be the number of overtime hours times the hourly rate. So this overtime is a function of the hours. Our inventory is going to simply be the inventory holding cost in our inputs page multiplied by the, let's see if I can zoom up a little, I can't while I'm in there, multiplied by the number of units in inventory for every period. Just a little bit larger. Our stockout cost is also the number of units we calculate for our stockout. This will be our backlog quantity that we need to satisfy in later periods. The inputs multiplied by the on the input page, the cost of stocking out, the $5 per unit, multiplied by the units of stock out that we calculate. Here's the subcontract cost. Again, the number of units of subcontract. If we can't satisfy everything and the solution determines that it's better to outsource some of this, we will have a subcontract quantity of units in every period, and we'll multiply that by the $30 subcontract cost. Finally, our production cost. All the units produced will have the variable cost of production as the inputs multiplied by the number of units produced. So here we specifically account for the variable cost of production in terms of material cost. So that's the development of our objective function. I guess I should go back to the model and quickly point out that, of course, the total cost is simply a sum of all of these, as I identified previously. And, of course, this is the cell we're going to be optimizing on. We'll be minimizing on that cell. Okay, constraints of the linear programming model serve to balance the operating conditions of the plans subject to the inputs, the policies of the company, or natural limits. So inputs could be the demand satisfied for each period, of course, the beginning and ending and any safety inventory balances. The policies would be the limit on overtime per worker per period, and natural limits like the balance of inventory is a natural calculation. The balance of the workforce is a natural calculation of that balance. The workforce size in each period is a function of the number of workers in the prior period plus the hiring and less the layoffs. Again, linear programming requires that all constraint equations must have a constant on the right-hand side of the equation. So with algebra, we reformulate our constraint for the workforce being workforce in the prior period plus hiring less layoffs to be this calculation here. Now note that W0 is 80. We begin with a beginning inventory or a beginning workforce of 80 employees, 80 workers. The capacity in each period is a function of the number of units produced and a relationship of the amount of capacity used for each unit. So in this example, labor is the capacity constraint. The total number of labor hours per unit is multiplied by the number of workers available. So these are the labor hours per unit times the workers available per month. So this is a labor hours per unit times the total units that a worker can produce in a month. If you take 160 hours, you divide it by 4 labor hours per unit, that gives you 40 units per period. Or excuse me, 40 labor hours per period. So we multiply that 40 times the number of workers. Now, overtime is considered by adding in the total overtime hours divided by the labor hours per unit. So when we calculate the total number of overtime hours, we will divide that by 4 hours per unit to determine the number of units made with overtime. So that's our calculation of the units produced with overtime.